In this section, we're going to work with a method of solving quadratic functions that can't be factored by completing the square. And what completing the square basically means is I'm going to create a binomial on one side, squared. Let's just say that this equals some number we don't know. And the point of completing the square is so that then I can square root either side of the equation. And then I can find the value of x because I've managed to get it out of being x squared. So again, I'm just sort of using any old number over here. Okay, so if I go ahead, I complete the square, then I can square root either side of the equation. In our last lessons, we learned how to solve quadratics by taking square roots. That was preparing us for this. Essentially, completing the square is taking a standard form quadratic function and putting it into vertex form. Remember, vertex form has a binomial squared in it. Okay, so that's what we're going to work with, solving quadratic equations by completing the square and transforming from standard form into vertex form, which are basically the same activity. So the key vocabulary here is completing the square, and we'll talk about that in a little more detail. This is it generically, and we'll talk about that in a little more detail in a second. So a type of problem where we might work with this is a function like this, where we're trying to find the height of maximum height of a baseball that's been struck. So they've given me a quadratic function. Generally, items that have been launched into the air or dropped from the air can be modeled, the path can be modeled with a quadratic function, and in this case I want to find the maximum height of the baseball. Well, we know the maximum height is going to be the y-coordinate of the vertex. If I put this equation into vertex form, then it'll be very easy to find. Okay, so we're going to use that skill. Remember, the vertex is the highest or lowest point in a parabola. Because this parabola opens down, because it has a negative leading coefficient, we know that the vertex will be the maximum value. If it opened up, the vertex would be the minimum value. So this is a diagram of what we do when we complete the square. So if you imagine that we've got this part of a quadratic function and we want to make the perfect square of a binomial. Remember, perfect square of a binomial we learned earlier also in this chapter. So we're creating these guys, and what happens is I've started with this, and to complete the square I have to add the correct value of that to make the perfect square. So when you look at how do I find that, if I have x squared plus b times x, that could be modeled here. See, it's x times x, and this area here is b times x. And if I split this in half and move it over here, you see I've made almost all of a square. So when I take this value, this length is half of the b, so I divide it by 2. And in the end, we have this distance is b divided by 2, and this distance is b divided by 2. So together these make b divided by 2 squared. So when I add that value in here at the end, then this simplifies to being this value. So remember, as you're creating the difference of two squared, or sorry, as you're creating the perfect square of a binomial, you notice that these values here are the values that end up here. Okay, so this is sort of generically how it looks. As I go through explaining how we do this, I'm going to use this shape over and over again to try to hone into you how you use b divided by 2 almost exclusively to create this scenario. All right, and then how the different values flow into the square of the binomial. So when we look at a problem like this, remember I have n squared plus 16n. So if I start laying that out, this would be n times n. And this item here would be n times 16. Now if I split this in half, that means that this distance and this distance are both 8. right? So they're half of 16. So when I move them over here, this is 8, this is n, and you can see that n times n would be n squared, right? I'll have n squared. And then I'll have plus 8n, right? Because this distance here is also n, as is that. Plus 8n plus 8n, because I have 8n here. This is 8n. This is 8n. This is n squared. And together, when I combine those, I have 16n. And you see that matches what I've started here. So what is this size? Well, you see that this length is 8, and this is 8. So this would be 8 squared, which would be 64. And this is the square of a binomial. So what's important then is what goes in the binomial. So I know it's the square of a binomial. I know that I'm going to take this value, right? This value here, and this value here, and I'm going to use this sign here. Okay, so it's going to be n plus 8 squared. Okay, so again, if you think about, if instead of writing 64, and this might be an easier way for you to think about it, if I write it as n squared plus 16n plus 8 squared, then again it might be even easier to identify the parts that I need for my binomial. There they are. Okay, so n plus 8 squared. Okay, so if that's equal to 36, the point here is I'm going to square root either side. N plus 8 will be equal to plus or minus the square root of 36. So n plus 8 will be equal to plus or minus 6. And if I subtract 8 from either side, n will be equal to negative 8 plus or minus 6. So negative 8 plus 6 is negative 2. Negative 8 minus 6 is negative 14. And those are my solutions. Okay, so what did we do? We found the perfect square of a binomial. Once we found the perfect square of a binomial, we square rooted either side of the equation, and then we can push through to a solution. So let's take a look at another example like that where it's already a perfect square. So I know I have x times x here. You notice now that I've got the minus though, right? So this whole distance is 18, but that means that this is 9 and this is 9. So when I move those over here, 9 and 9, that means this is 9 and 9. So this would be x squared, and this is going to be 9 squared. So I have x squared minus 18x plus 9 squared is equal to 5. Remember when I worked through transforming this perfect square trinomial into the square of a binomial, these are the parts I'm going to use. I'll have x minus 9 squared is equal to 5. And when I square root either side, x minus 9 is equal to plus or minus root 5. And the last thing I'll do is I'll add 9 to either side. X is equal to 9 plus or minus root 5. Okay. You don't need to put this into decimal form. This is a perfectly satisfactory answer. All right? Now let's look at, those were nice because both this one and this one already started off with perfect square trinomials. But really, completing the square is about making the perfect square trinomial. It's very rare that they just start out that way for you. Okay, so remember, this area will be half of that. So 12 divided by 2 is equal to 6. So this will be 6, and this will be 6. I know this is x squared, and this is 6x, and this is 6x. So x squared plus 6x plus 6x, that's x squared plus 12x. So what's this distance here? Well, it's 6 times 6, or 6 squared. So I would want to add 36. X squared plus 12x plus 6 squared. Remember, I could write that as 36, but for my purposes, remember, I want to make it a square of a binomial, and to do that I need that, that, and that. I don't so much need the 36. When we're working with an equation, I'm going to add 6 squared to this side, but I'm going to add 36 to the other side, so that will be important. So this is x plus 6 squared. If I want to check to see if this is correct, I can multiply it out and see, did I really make what I thought I was going to make? So x times x is x squared, x times 6 is 6x, 6 times x is 6x, and 6 times 6 is 36. X squared plus 12x plus 36. That checks out to what I thought I was going to make. Okay? And this square, if you work with a square like this, it will help you stay focused on getting these values correct. Okay, here's another one, a little more complicated, just because 13 divided by 2 doesn't really simplify to be anything that's comfortable for us to use. It stays as this improper fraction. I really don't want to make it 6.5, because what I want is this value squared. Okay, so when you start looking again at how do I make my, right, I'm going to have that and that. How do I make my binomial? The key is the sign and then this value here. Okay, so I'll have x squared minus 13x plus 13 halves squared. You'll notice I didn't square 13 halves because I don't really need it right now. X squared minus 13 halves is what I want squared. If I was working with an equation, then I would have added 169 fourths to either side, because that's 13 halves squared. Okay, let's put that in an equation and see how that works out. Right, I'm going to take 8 and divide it by 2. That's equal to 4. So this is x, this is x, this is 4, and that is 4. And that means that this is 4 squared. Okay, so I'm going to have x plus 4 squared. And how much did I add to either side? Well, let's go back and let's write it out. X squared plus 8x plus 4 squared, which would be, I'm going to write 4 squared, but that's 16, equals negative 1 plus 16. So if I add 4 squared to either side, I can put it as 4 squared here. I put it as 16 over there because it's easier. Now I'm going to take the square root of either side, so x plus 4 will be equal to plus or minus the square root of 15. And when I subtract 4, x is equal to negative 4 plus or minus root 15. That's fine as an answer. I can't simplify root 15 anymore. If I could, I would, but I can't. Okay, let's take a look at another example. Okay, this is a little different. You'll notice here I had it equal negative 1, so I only had the x squared plus 8x here. This one's a little more complicated because I've got this 86 here, and I'm not sure what I should do with it. The point is, I want to take these parts and make a perfect square trinomial. 86 doesn't help me. So I'm going to move it to the other side of the equation. So I'll have x squared minus 18x equals negative 86. So I subtracted 86 from either side of the equation. And now I can start working with this. 18 divided by 2 is equal to 9. So x goes here, 9 goes there, and 9 goes there, and this is going to be 9 squared, which is 81. So if I add 81 to either side, x squared minus 18x plus 9 squared, so I added 81 there, negative 86 plus 81. I know that this becomes the square of a binomial. Remember, I'm going to use the x, I'm going to use the minus sign, and I'm going to use the 9. So this is x minus 9 squared equals negative 5. And when I take the square root of either side, x minus 9 equals plus or minus root negative 5. Well, root negative 5, I know that that is I root 5, right? So I factored a negative 1 out, right? If you think about this, this is the square root of 5 times the square root of negative 1. Negative 1 equals I. Okay? And now the last thing I'm going to do is add 9 to either side. X is equal to 9 plus or minus I root 5. And that's completing the square. Okay, one more example. But now we want to write in vertex form. Remember I said, though, it's essentially the same thing. The difference is that when I was done with this 5, I would have moved it to the other side to get back into this form. That's where the k would come from. So the first thing I want to do is I want to get rid of this 37. It really doesn't help. Y minus 37 is equal to x squared plus 12x. Then again, if you think of, right, I have this thing. This is x, that's x. Half of 12, 12 divided by 2 is equal to 6. So this is 6, and that is 6, and this will be 6 times 6, so 6 squared. So what I'm going to add to either side is 36. So over here I'll have y minus 37 plus 36 is equal to x squared plus 12x plus 6 squared, which is also 36. Minus 37 plus 36 is y minus 1. This is the perfect square of a trinomial, or perfect square trinomial, so the square of a binomial. Those are the values I'm going to use. X plus 6 squared. And now when I add 1 to either side, now I'm in vertex form. Remember, vertex form is this right here, so you can see h in this particular case is equal to negative 6. K is equal to 1, so my vertex is at negative 6, 1. It didn't ask me to do that, but it's important to think about what is part of the value of putting it into vertex form is finding the vertex. If my primary goal in a problem is to find the vertex, I might want to consider putting it in vertex form as opposed to working in standard form. Also, we use the completing the square in order to solve quadratic functions that can't be factored. So you notice we came through and we got solutions for all these different equations that couldn't be factored. Okay? We'll use it for some other things as well. All right, so f of x, remember that's the same thing as y equals 2. Right, same thing as this. I'm going to get rid of the 4 by subtracting it from either side. And then I'm going to take 3 and divide it by 2, right, which is going to equal 3/2. And I'm going to square it and add it to either side of the equation. So y minus 4 plus 9/4, that's 3/2 squared, is equal to x squared minus 3x plus 3/2 squared. I want common denominators of 4, so this is going to be y minus 16/4 plus 9/4. It's going to be equal to, and it's going to be here we're going to have a binomial squared, the x, the minus sign, and the 3/2. Okay, so I'll have x minus 3/2 squared. Now, when I simplify over here, negative 16 plus 9 is minus 7/4. X minus 3/2 squared. And when I add 7/4 to either side, I'll be in vertex form. Okay, so in this case, my vertex would be at 3/2, 7/4. That's my vertex. Okay. Another thing we're going to use completing the square for later in this course is in working with conic sections as we go ahead and write conic sections into standard form. So this is it's an important skill to learn. It's a pretty easy form to learn to solve quadratics that can't be factored. It is, once you master it, and it doesn't take a lot of effort to master it, it's a lot easier to get correct answers from than the quadratic formula, which we're going to work on in later sections. The quadratic formula is very nice in terms of the fact that it will solve any quadratic function, but at the same time, using one algorithmic method to solve really doesn't help in terms of the development of your critical thinking skills. And the quadratic formula has lots of little steps within it that students are prone to making mistakes in. So generally I use the quadratic formula for myself, and this is what works for me, not necessarily what works for you. I use the quadratic formula typically as a last resort when I've failed in all my other attempts to solve. So returning to the problem we were going to work on with the flight of the baseball, we know that we needed to find the vertex. Here's the equation that we have. And what we're going to do is we're going to move this 3 to the other side. Y minus 3 is equal to negative 16t squared plus 96t. I'm going to divide 96 by 2, which is equal to 48. I'm going to square 48 and add it to either side of the equation. So when I do that, I'll have y minus 3 plus 2304 is equal to negative 16t squared plus 96t plus 48 squared. Now remember, I write it as the value squared on this side because the 48 is the number I'm looking for. Oh, but I made a mistake. You notice in all the other problems we worked on, I had a leading coefficient of 1. This doesn't work. If I try to make this now, if I do negative 16t plus 48 squared, and I tested this isn't going to come out to be that. So I've got to stop and I've got to do something different. To complete the square, I need to have a leading coefficient that's 1. So before I can really begin this problem, I'm going to go back and I'm going to just erase the whole thing. Before I can begin this problem, I need to divide everything by 16. So I can do y minus 3, I can still do that, is equal to negative 16t squared plus 96t. So what I need to do before I start looking for the value to square is I need to make my leading coefficient be 1. So I'm going to divide everything by negative 16. Okay, so y minus 3 over negative 16 is equal to t squared minus 6t. Oh, well, that's a lot easier actually when you look at it. If I go ahead and I'm going to go ahead and distribute some of this division over here. So I'll have y over negative 16 plus 3 over 16. This is going to be equal to t squared minus 6t. Okay, if I bring this up over here and continue to work, I'll have y over negative 16 plus 3/16. And remember, I'm going to take negative 6, I'm going to divide it by 2, that's 3. So I'm going to add 9 to this side, and I'm going to add 9 to the other side. But I'm going to add it as 3 squared. Okay, when I go ahead and simplify here, I know I'm going to have y over negative 16, that's still there, is equal to 3/16 plus 9. Well, how many 16ths is 9? It's 144/16. So, sorry, plus 3/16 plus 144/16 is equal to, this is a binomial, t minus 3 squared. When I combine these guys together, I'm going to get 147/16. So y over negative 16 is equal to t minus 3 squared minus 147/16. So now I've gotten it pretty well into standard form, but I still have this -16. So what I'm going to do now is I'm going to multiply everything by -16. So I'll get y is equal to -16 t minus 3 squared, and minus 147/16 times minus 16 becomes plus 147. So now I'm in vertex form. I see that my vertex is at 3, 147. And now when I return back to answer my question, find the maximum height of the baseball. 3 seconds after it was hit, the baseball was 147 feet high. 147 feet. That's my answer. Okay, so key things to remember. If I'm going to complete the square, my leading coefficient has to be 1. If it's not 1, what do? I divide everything by that number to make it equal 1, and then from here, I can proceed and complete the square.